Hello, my name is Tomasz Heimowski, and this is a talk I've given at FableConf this year in Antwerp, and it's about web remote control. I'm recording this right now at my home because we had some technical issues, so we weren't able to record a session during the conference. But I'll try to go through the slides and the demonstration as I did at the conference. A few words about myself. I'm a software contractor working for Datto, and this session will be about the project that I've been involved to for a previous year or so. And as you can see, the slides are also branded with Datto, but I also do some open source stuff related to Fsharp, and if you want to trace my activity related to Fsharp and open source software, then make sure to check out the Heimowski nickname and have a website as well as a GitHub and a Twitter account. The goals of today's session is to first and foremost show a success story using Fable, because I believe that Fable is still in an early phase where stories like this one, using an advanced application, and actually the application I think is pretty cool, and stories like that should drive the adoption of Fable. So this is the number one goal of this session. But in addition to that, I'd like also to share some practical tips as well as discuss challenges while creating applications using Fable. And the plan for the session is to first show you some of the context of what is the project about, why was it started, and then I'm gonna show you a demo of the working product, and then we'll talk about the technical solution on the front-end side. And finally, I talk about lessons learned during this adventure and make a recap. So first, let's start with context of what is exactly Datto, what is Datto RMM, and what is web remote control. So Datto is a company which does quite a lot of cool projects, and one of them is called RMM, which stands for Remote Monitoring and Management. And I'll try to explain in my own words what this means. So let's imagine that there's, for example, a furniture company, and the furniture company has some computers within it. So boss will have a MacBook Air, for example. There will be a accountant working on a Windows 7 PC and some legacy mail service running on a Windows Server 2008. And we'll call those computers collectively devices. And the furniture company could have its own administrator to monitor and manage those devices, but nowadays it's a common practice to delegate that task to a third-party company. And there are a lot of companies that provide IT services. So let's imagine that there's a company there's an IT services company called All in Cloud, which provides those services to our furniture company. And obviously, it will provide those services to more than just a single business. So imagine, for example, local restaurant or a hospital or whatever you can think of. And we'll call those businesses collectively sites. And the IT services all-in-cloud company could go on site to those businesses and help them with their devices and computers. However, that wouldn't scale really well, and that wouldn't be really practical. So instead, what they do is to use software to manage and monitor those devices. And that's where Datto RMM comes in. And there are a lot of businesses or IT services company that we call managed service providers or MSPs, which use our software to control and manage and monitor a lot of their sites which have a lot of devices. So that's basically how Datto RMM works. And where is remote control in that whole picture? So basically, what is remote control? If you've ever used Windows servers, if you have ever needed to control a Windows server, you probably have used remote desktop protocol. So that's for maintenance. If you need to install application or check your web server or whatever you need to do on the Windows server, you do maintenance and use remote desktop to control that. But remote control is primarily about support, also a bit about maintenance, but primarily about support. And in general, it comes with a set of auxiliary tools that help a technician to resolve an issue. So basically, when a customer has some problem with his computer, he will ask the MSPs, the managed service provider, to take care of his computer, and the technician can use remote control to basically fix an issue. And the most popular tools in this area is probably TeamViewer or recent project by Google called Chrome Remote Desktop, which does the remote control via a browser extension. So that's pretty close to what we have, because we also use web technologies for the project. And the primary use cases for remote control within Datto RMM is, as I mentioned, when the end user asks for support because, for example, his computer is acting slowly or something doesn't work as expected, he'll basically call the support and ask for help. The other use case is within Datto RMM, you can configure alerts. So, for example, if the CPU is running under 90% of consumption for more than 10 minutes, you can configure an alert to be triggered when that happens. And then the technician will get a notification that he or she should fix the issue. So one way of doing that is using remote control to take over control of the end device and troubleshoot and resolve the issue. The most common scenarios for that will be using a set of administrative tools, everything that helps to solve the issue: control panel, command prompt, PowerShell, etc., etc. But in addition to that, the technician might also want to grab some log files from the end device. That's where he needs to have the file transfer functionality. It's also possible for him to upload a tool that will help to investigate the issue. For example, if he likes to use Process Explorer, he can use that to troubleshoot the issue. And there are already remote control solutions within Datto RMM, but they require Windows operating system and they need a dedicated application. And it's also using licensed commercial third-party tool. That's why the Datto team decided that new remote control products should be started. And there were some initial requirements around the project, among which were that it should be browser-based, which means that there should be really no plugins required. It should be just pure HTML, CSS, and JavaScript solution. And in addition to that, we really wanted to take a technology step forward. So to be able to optimize the speed and to maximize the reliability, that were basically the initial requirements. And the question is why Fsharp and Fable have been chosen for the technologies for the front-end application. And the background here is that basically the engineering teams within Datto RMM are split between the platform and agent part. So for platform, you can think of all the things related to databases, services, and all the services running in the background will be the platform responsibility, as well as the web application itself. And for the agent, it will be the software that's actually running on the very end device or the computer. So it runs there to collect data and to be able to communicate with the platform. And you might think that because the new remote control solution should be browser-based, it should go to the platform team because they are already handling the web application. However, it's been decided that remote control should be really an agent project because there's a really tight coupling between the client and server, so in this case between the browser and the agent. And otherwise, a lot of changes would need to be synchronized, which would be not really practical. And because the Agent Console application is already using Fsharp, and the Fable ecosystem is friendly for developers who are maybe not very knowledgeable in the web area, the decision has been made to try out Fsharp and Fable for the application on the front-end side. And that's basically the story how I got employed by Datto to start and lead this project. And also what's worth mentioning is that simultaneously to the new platform, to the Web Remote Control project, there was the new platform UI project. And that's important because this new UI project is maintained by the platform team. So Web Remote Control will be maintained separately, but because they are both web applications, they really should have the same look and feel and the same user experience. So they should really have the same layout and the same CSS, style sheet, etc. So because the new UI project is much bigger on the front-end side, it basically was already using some layout libraries, and it influenced the layout of Web Remote Control, which means that we were required to use certain libraries for the layouts. And now let me show you a demonstration of how Web Remote Control works in practice. And I'll show you a version that's currently working in production. However, I decided to show that from my local host environment because for demo purposes that will be much faster, and I probably won't get into connectivity issues. So you will see the application running on my local box. And that's my browser tab with the application open. So let me refresh the tab to see what's going on. So when the application is starting, you can see the connecting status with a stopwatch indicating how many seconds it takes to establish the connection. And we measure that because we care about the speed. And what we do is a fancy thing that we display a notification when the connection is established with an information how much time did it take to actually establish the connection. And we compare that speed to sports cars. So how much does it take for a sports car to accelerate from 0 to 60 miles per hour? And let me maybe refresh once again so that you get the idea. That time it was 8.1 seconds, and this time it's actually the same. So maybe let's try once again so that we can maybe see a different car, hopefully. Right, so basically, depending on what's the connection speed, we'll get a different car to compare. So a small feature, but actually the clients quite like it, so good stuff here. Okay, so basically what you can see is the remote session, the remote screen, and we have some basic keyboard and mouse integration. So for example, I can go from here and open up a notepad where I'll type in hello world from FableConf. So as you can see, the standard mouse and keyboard integration over here. And that's the remote session, and the auxiliary set of tools that I talked about is here on the right hand side. And when the technician logs into the device, he can immediately see the performance tab, which shows the CPU, memory consumption, as well as disk and network usage. And this can help to initially assess what's going on with the device. Then there's a connection tab, which basically displays the quality of the connection, so that we can assess the quality of connection to say whether it's fast or not. In this case, the latency is quite small because, as I said, it's running on localhost. Then we have a couple of display options. So first, maybe let me show you what I can do when I go full screen. I can hide this side panel and work like in a really full screen mode if that's the desired way of things. But otherwise, let me close full screen now. Otherwise, we have two modes of displaying the screen. So the default one is fit screen, but we also can do original size, which makes the remote display 100% scale. And whenever it's bigger than our current area where we can display the screen, we show this red minimap, which shows us the context of what we can see on the screen. So let me move to the fit screen option, and let's go briefly through the rest of the options. So we have a couple of functionality for the keyboard. So for example, I can open up an on-screen keyboard, which is pretty handy when using a mobile device. So keep in mind, because it's a pure HTML solution, you can also use your iPad to control a device, and that's where it gets useful, this on-screen keyboard. We have a send Ctrl-Alt-Delete sequence button, which allows us to do that with a single click. And there's also send clipboard as keystrokes options, which is handy whenever the technician needs to, for example, copy a password to a Windows login screen. So by default, we do have support for copy and paste. However, by default, the Windows login screen will disable the paste action. So what we do here is we emulate the keystrokes as reading from the clipboard. Then we have a quick launch section, which allows to open up a program with a single click. The most useful programs like Control Panel, Event Viewer, or Task Manager, they are there with just a single click, so it's really useful. Then we have file transfer section, which allows to either download or upload a single file. So what I can do is to click download file, which open a pop-up on the end device, and I can choose a file to download. So let me download this picture over here, and I get the native browser behavior for downloading a file. So if I downloaded that to my computer, I can open that locally on my MacBook. And then I have an option to upload a single file, and for that purpose, I'll use a bigger file so that I'm able to show you the progress bar for this. So I have a 500 megs file, and because we are on localhost, the speed is very high, and that's why I chose a bigger file to show you the progress bar. So when uploading, I can see the progress. I could cancel that, but let's make it finish. So when that happens, the file is being uploaded to the desktop location, and I can access that from within the remote session. And finally, we have a reboot capability. So if it's necessary, then we can send a normal reboot or safe reboot commands to the end device. So this is pretty much it with regards to demonstration, and we briefly saw how core features of web remote control work, and we established the remote connection to the end device. What I showed you is how to establish that connection to a Windows box, but we also have support for macOS. And when you log in, you can immediately see the performance graphs, which allow to assess what's going on with the device initially, as well as the connection graphs to assess whether your connection is good enough. Then we have a couple of options to control the display size, keyboard and mouse emulation and integration. And actually for iPad, we also have this mode of touchscreen or touchpad, which is really handy to use for mobile devices. Then we have the quick launch option for quickly open most used tools with a single button click. Then there's a file transfer functionality to either upload or download a single file. And finally, we have the reboot capability to, if necessary, we can reboot the end device. So let me now go through the technical solution on the client side and talk about libraries and tools that we used to implement that. And obviously Fable, because otherwise I wouldn't talk about the project. So we do use Fable, and I added that for completion, this slide. However, I think the most important project here is Apache Guacamole, because it comes with ready support for an HTML5 client. So basically it comes with a JavaScript file, a JavaScript library kind of file, which you can grab and use on the front-end side. On the back-end side of things, I will skip the implementation details, but it allows to plug in different protocols. But the most important thing from the client-side perspective is that we can use that HTML5 client, this JavaScript file, and it will basically create an HTML5 canvas and draw the remote screen on that canvas. The Apache Guacamole comes obviously with the Apache license, and because it's not that very popular, there are no Fable bindings. So what I had to do was to create and inline our own bindings. So by inlining, I mean the sources for the bindings are within the project itself. Next, Elmish, no surprises here. What can I say about Elmish? Model view update for the win. So basically it was really easy. For example, the initial state where you have the stopwatch with the connecting status, to implement that logic with MView. This is a really piece of cake. And one thing worth mentioning is that due to the chatty Guacamole protocol, so whenever I move my mouse around this HTML5 canvas or type in something on my keyboard, I subscribe to those events, and they are then translated to Elmish messages. So there are lots of messages flying around, and because of that, we decided not to use the console trace for the development, but instead what we do is we have this separate debug section on the right hand side, which we use for seeing what's going on in the development mode. Then React.js, I'd say that probably nowadays it's the go-to framework for Fable applications because it really integrates nicely into the Fable and Elmish mix. But we had an issue with React.js initially because this Guacamole JavaScript library is not based on React, and it manipulates the DOM. So that was an issue for me initially, so started without React. But eventually, when I learned how React works under the hood and how the lifecycle works and how in-controlled inputs works, I managed to integrate React and Guacamole, and we actually ended up with a nice separation of concerns. So separate component, if you like, will be handling the integration with Guacamole, while the rest of Elmish components will try to follow the best Elmish practices. Then for the CSS framework, we use design, and we are not using the Fulma project because design was already used in the new UI project, which I mentioned at the beginning. Because of that, we were restricted to use design, and there are Fable bindings for this framework. However, they are pinned to the old version of Fable. So because we want to use the latest bits of Fable, what I had to do was to take those bindings, inline them into the project, and fix the issues with the Fable incompatibility. And we use just a few components from the framework, so I didn't have to translate everything, just the components that we use. And I haven't yet contributed those changes back to the project, but I'd like to at some point. And another library that we needed to use is eCharts. So this is for the charting library. And I want to emphasize that it's different than recharts. So the name collisions in JavaScript libraries might be, there's a high chance that you can mislead between to JavaScript libraries by its name. But what's important is that the recharts comes with Fable bindings, while echarts does not. And again, we had to use the echarts library because it was already used in new UI project. And because it came with no Fable bindings, we had to create and inline again our own bindings. And because currently we're just using simple line charts, I just took the minimal functions necessary to create a line chart with echarts. And finally, Toaster for popping up the notifications, for example, the one that you saw when the connection was established. And there are Fable bindings already there, so it was pretty handy to use in the project. We also use the Toaster to display errors that could occur during the connection. Okay, so let me now talk about lessons learned during this adventure. And first thing, let me talk about integration or interop with JavaScript libraries. And basically the story is that if you want to integrate a JavaScript library in Fable, you either find a binding that that's already created for Fable, but not all libraries might have that binding, or as was in my case with for example, Guacamole or echarts. And there might be bindings for Fable, but it might be outdated, so use an old version of Fable, which was the case for me and design. And if that's the case, don't give up on Fable, because it's pretty simple to do the bindings yourself. So you can either use the TypeScript bindings if there are for a project, and you use the TS2Fable project to transform between TypeScript bindings and Fable bindings. But if there are no TypeScript bindings, or if what's also possible, it fails to translate the TypeScript binding to Fable, because there are some types in TypeScript that do not map one-to-one easily to Fable and Fsharp. If that's the case, you can always create the bindings by hand. That's not very hard, and there's an excellent guide by Zaid that shows how to do that. And the key point is that you probably don't need to bind everything at once, as was the case in my example for echarts. I just took a couple of functions and created bindings for them. And if everything goes well, you can take those bindings from internal to a more public relation and open source that eventually, which I didn't do yet, but I'd like to at some point. And yes, so the key takeaway from this slide is that whenever it happens that you miss a Fable binding for a library, don't give up, because it's pretty simple to create one yourself. Now let me talk a bit more about the initial problem that I had with React and integrating with Elmish and a third-party JavaScript library manipulating DOM. And in that case, it was the Guacamole library. So here's a snippet showing what I call a hello world from Guacamole, and that comes from the Guacamole documentation website. So basically, taking aside all the things on the backend, assuming that we have the backend stack already in place, on the front-end side, what you need is a single div with an ID, let's call it display, and then a couple of lines of JavaScript code. So we get first a reference to the element by its ID, and then we create an instance of a WebSocket tunnel and a Guacamole client using that tunnel, and the client has a reference to a display and the HTML element. So what we do here is we grab that element and add it to DOM by using display append child. And then we call the client.connect method on the client instance, so that triggers the connection. And the key point here is that Guacamole client keeps track of the HTML5 canvas, and it will, under the hood, update and draw on that canvas when the connection gets some frames from the backend. And we can basically take this code, this JavaScript code, and translate that to Fsharp. So the corresponding Fsharp Fable code looks quite the same, actually. The only thing is that you need those Guacamole bindings, so this is using the bindings that I created, but the rest looks pretty much the same as the JavaScript corresponding code. So now let's try to add Elmish to this application. So what we can do is to create a React element, a div element with this ID of display, such as before, but this time it will be a React element, and then call mount by ID function, which will look for this Elmish app element within our HTML and mount the index React element there. And this is probably not the best practice to do that, but this code works. And now let's try to add, sorry, so this was not for Elmish actually, but just for React. And now let's try to add Elmish to the mix also. So to create an Elmish application from that, I need to have this Elmish architecture model. But because nothing's going on really right now, I just use dummy type for the model and dummy type for the message. And because I want the connection to happen initially, I move those lines to the init function. So the connection logic will be in the init function. The init itself will return empty model and no comments. The update function is also a dummy function here. Basically just view renders the div with the ID of display. And then we use init, update, and view to create the standard Elmish program. But there's an issue with this code, and it will throw at runtime. And it appears that when we reach this line of code, the display element is null. So there's no display element at this point when we reach this line of code. And basically, it appears that how React works, if we really simplify that, is that there's a lifecycle for React, and the important thing is that until we reach the mount state in React lifecycle, the corresponding element is not there in the HTML file, in the HTML DOM. And to fix our previous issue, what we can do is to listen for that mount event whenever that happens. So one way of doing that is to use a ref property which takes a callback that is triggered whenever the element is actually mounted in the DOM. So here what I'm doing is I'm dispatching the display mounted event or message that I added to my messages. And then I extracted the connection logic into a connect function, so I'm no longer doing that in the init function, but instead, when the display mounted message comes to our update function, we then call the connect. So now this logic will be called whenever the display is actually mounted, and it works. But we still refer to the element by ID, so we can do a little bit better than that. And because, as you see here, this element mounted to DOM is passed as an argument to that callback, we can use this fact and add this element as a field of display mounted message. And then basically, when we dispatch that message, we can use this argument here to get the reference to that element. And again, it might not be the best pattern to follow, but I just wanted to show you how, if you know React, you can figure out how to fix certain kind of issues. So the takeaway from this is that it's good to know what you are using, because the most basic usage of React in Fable application is pretty simple. So you just drop divs and other HTML elements in your code, and it works. But it gets tricky when you need to do something more fancy, like in my case, integrate a third-party library that manipulates the DOM but does not reuse React. Or, for example, if performance starts playing a crucial role. And in those cases, it's really helpful to understand how React works under the hood. And now let me talk about the parent-child architecture in Elmish. And here I have a snippet copied from the Elmish documentation, and that presents a simple component, a single component. This is a counter component, and it has its model, the init function corresponding messages for incrementing and decrementing, and an update function. And it might be that when the application is really small, you might use just a single component for the whole application, but really in practice the applications get more complex than that, which means that you need to boil down to the parent-child architecture. And here I have another snippet from the parent-child site from the Elmish documentation, which shows this concept. So here we have top and bottom counter models. So our model right now keeps track of 2 children, and all it basically does is it's orchestrating the messages going between one and the other, and that's basically what's called parent-child architecture, without going into much details right now. So as I said, complex applications and the real-world applications usually imply the parent-child architecture, because otherwise the component would be too huge. But if you go to the examples in the web, most Elmish examples will demonstrate that parent-child architecture on the sample of subpages. So basically, if you have a navigation or menu that if you click certain options, you get navigated to a different subpage. But how should we structure the components within parent-child architecture if we're dealing with an app that doesn't use subpages, as is the case for me? And my initial attempt at that was to use a really thin parent and lots of children. Basically, there would be a separate child for every single functionality within the application. But this approach led to lots of dependencies between components and really unclear separation of concerns. And if I were to picture that somehow, you can imagine what it looked like. So I would have separate components for every single functionality within the application. So it didn't work out pretty well, and eventually I ended up with a solution where I moved most of the logic to the main component, to the parent, and have much fewer children right now. And drawback here is that the parent component, the app component, is a bit bigger right now, but it's still maintainable. But the advantage is that I have fewer dependencies for the messages, and the separation is pretty clear. And now I'll only extract another component if it really makes sense and it doesn't lead to multiplying the dependencies. And the children components that I currently have is for the performance and connection graphs. So because they can be pretty much isolated, it makes sense to create a separate component for those. Then I'd have a client adapter component, which basically works as an adapter on top of the Guacamole. And then a component for clipboard helper functions, as well as for the display. So the display one is actually quite bigger, because it requires a bit more logic to compute whether to display this minimap, how to control the display size, etc. And now let me talk about a concept that I call separate message types. And this is a really simplified version of the message and update function from the client component that I mentioned a second ago. So this is the component that's acting as an adapter on top of Guacamole. So I removed most of those messages from there and just left the one that demonstrates the concept that I want to talk about now. So let's go through each of the message separately. So first message is connect, which comes from a different component and basically instructs our component to invoke client.connect. So like invoke a side effect somehow. And then we also want to create another message. In this case, it will be connected. And the connected message is really meant for different components. So when we handle that in the update function, we basically ignore it and return current model and none for comment. And then I have a mouse event message, which basically is triggered by the client itself. So we subscribe to that in the same component. And when that message happens, I want to propagate that mouse state back to the client, as well as create a mouse activity detected message. So this message is again for an outer component, so a different component which keeps track of the idle time, which means basically that if you're idle for more than 30 minutes, you will get disconnected. And because mouse activity detected is a message meant to be consumed by a different component, we ignore that within our component. So you can spot a certain pattern here in this update function, which I decided to make explicit. And to do that, I use 3 different types for the messages. So I'll have an internal message with a private constructor, as you can see. So those are just the messages that are meant to be subscribed to and triggered by the component that we currently handle. And in this case, it will be the mouse event. And I have 2 corresponding functions for the internal message. One is for the side effect, if you like, so I'll call the client send mouse state over here. And then I have the internal update function, which basically is able to create a message from or a comment from that internal message. And in case of mouse event, I basically want to create the mouse activity detected message. And then for the incoming message, this union keeps track of messages that are coming to our component, and we should handle them somehow. And in that case, I'll also have 2 corresponding functions. One for side effect, for connect, that will be basically client.connect, and one for incoming update. So I can create a message based on the incoming message, and in this case, it will be the connected message. And for both connected and mouse activity detected messages are meant to be consumed by a different component, so I put them in the outgoing message discriminated union. And I don't really need corresponding functions for those because I can pretty much ignore them in my component. And then I only need a wrapper on top of those 3 types of messages, so I'll have the type message keeping track of 3 different types of messages: internal, incoming, and outgoing. And my update functions looks like that and doesn't change when I add new messages. So for internal and incoming, what I'll do is to call the internal and incoming effect correspondingly, as well as the internal update to be able to create that comment. And outgoing will be basically ignored because they are just to be consumed by a different component. So to recap, the internal message will be only for the messages that are triggered by and consumed by our component. Then incoming messages will be for handling comments that are coming from outside of our component. And outgoing messages are those that are meant to be sent to different components. It gives a clear separation of those message types, and in my opinion, it works nicely for those side effectful components, like in my case is the Guacamole adapter. You might argue that the side effectful component is not the best practice for the Elmish architecture, but that's probably a topic for a different discussion. And also, following this pattern for all components would be an overkill, but in this case, for this side effectful kind of adapter component, it worked pretty well. And this, I also want to make credit to Maxim Mangal because this separate message types extends his idea of external message that he once posted. And code sharing. Thanks to the fact that we have a Fable F# application and F# console application, and the F# console application targets .NET Core 3 as well as .NET 4.0 for older version of Windows, we can have shared F# code. And basically everything that's related to establishing the relay connection, as well as the messages sent via WebSocket, are all the corresponding code is in the shared module. So for the device information, performance counters, quick launch instructions, or the file transfer operation, they're all modeled as types in the shared module, and the logic to trigger that is also there. For serializing, we use Thought.json library. So again, huge benefit from having F# on both ends. We don't need to duplicate that logic. And lastly, let me quickly talk about a set of handy functions that I came up with while working with the code. And the first set is really related to the fact of triggering messages after a specified period of time. And I have two functions here, after and every, which correspondingly call either Windows set timeout or Windows set interval. And they take an amount as a parameter, a function from a number to time span, and a message to trigger update that time span. And if I create helper functions for these time span constructors, if you like, I end up with a pretty nice small DSL for invoking the messages. So I can write something like every 3 minutes reset state, or after 5 seconds send message, which reads pretty nicely and doesn't require a lot of to do. But those functions are probably too small to put in a separate library, but feel free to copy them and use in your project if you like. One thing worth mentioning is that they don't support, in this form, they don't support the concept of canceling the subscription to the timer or interval, but you can add it. You just need to modify a bit those functions, and it's still possible to do that. And the next concept that I wanted to demonstrate is what I call forwards. And this is basically for the parent component in the parent-child Elvish architecture. So what I do when I want to propagate one message to the other, one message from one child to the other child. For example, one requirement was that I should propagate message called change scale from our display component to client component, the components to change the scale. And I can pretty easily declare that in this function over here. And if I don't want to propagate anything, I boil it out to an empty list. Then I can take that function and compose it with list map comment of message, and finally with comment batch. And the forward function is what I can now use in my update function. So for every child component, I'll have corresponding logic. So the standard child component updates child message, child model. And then in addition to mapping the child message, I also invoke the forward with that main message. So it will not only trigger the child message that's over here, but it will also take a look at these forwards. And thanks to that, when I need to propagate another message from one child to the other, I don't need to modify my update function, which can get pretty cumbersome with a more complex pattern matching, but I can extract that to the forwards function, which makes code a bit more clean. So that's the forwards thing. And to recap whole presentation, we have great feedback so far from clients, mostly about the fact about HTML solution, which is that you don't need any plugins and it works cross-platform. People can use the application from their mobile devices. We have heard feedback about it that it's faster, and people prefer to use that compared to competition, and that it's easy to use. So really nice feedback there. Although we still have plenty to improve. Probably mostly on the backend side of things. The client side of things is pretty nice. But on the backend side of things, we still need to improve the reliability, to minimize number of connection drops, and investigate bottlenecks with regards to optimized splits. But other than that, I can say that we had a great success with Fsharp and Fable because we have a successful production deployment. It still has the beta label. The product has still the beta label on it, mainly because those things that I just outlined a second ago, and we still miss a couple of features. But other than that, all is good. We managed to integrate the libraries that we had in Fable, so it was quite easy to do. Right now we're in a position where it's easy to add new features on the client side, so the code is really maintainable. And other members familiar with other members of the team that know Fsharp maybe don't know very well the web development, but if they know Fsharp, they can easily contribute to the project. And lastly, I want to say that I'd like to contribute back to the Fable ecosystem by publishing the bindings that I created during the course of this project. And by that, I'd like to say thank you. Thank you for organizers. Thank you to organizers for inviting me to the conference. And yeah, thanks. Take care. Till next time.